Leetcode video. Today we have max sum of a pair with equal sum of digits. So basically, we have a zero indexed array that has positive integers. You choose two indexes, I and j, right? They're not equal, and the sum of digits in the number I is equal to the number j. So basically, let's say, for example, 1 plus 8, which is 9, is equal to 3 plus 6, which is 9. What it wants is, it wants the maximum value of nums of I plus nums of j that you can obtain that satisfy the condition. So basically, you need to find a pair where their sum of digits is equal. So basically, like these two, sum them together, 36 plus 18, which is 54, right? And then you can have something like this, 4 plus 3, which is 7 and 7. Sum them up together, it's going to be 50. 54 is bigger, you turn the max, right? So, approaching this, there's a few ways to approach it. So basically, you can have, in these test cases, it's a happy scenario where you only have a pair of two. But what if you have like 18, 36, another 18, another 36, you have a pair of 4, or something like, instead of 36, probably 27, which is going to be the same. So the pairings are going to you're going to have to calculate all the pairings to get the maximum value of this sum of digits, right? To calculate the number of pairings is going to be a n squared solution operation where you actually have to like check every single one with every single one, sum them all together, which is not efficient. The better solution is to actually think about, we only need a pair for a digit. We only need one pair because it just needs a maximum value that you can obtain that satisfy the conditions where you can choose two indexes. So we need a pair. So how about we get the maximum two sums in a single digit sum. For example, 18, which is 9. The sum of them is 9, 8 plus 1. The maximum two values for this in this array is 36 and 18. That sum up to 9. So we only need to maintain 2 to get the top two maximum values for the digit sum of 9, basically, and then sum up together and then call it a day. So basically, something to use is like this is something I use the heap in this, which is very useful. Let's get into it. I looped over first the array nums, and I had this function which is calculate the digit sum, which is basically just does basic math. It calculates the sum of the digits, so 8 plus 1, 9, 3 plus 6, whatever, and I added them into a tuple next to the nums of I. So I have the sum, like the actual index and the sum of digits, and then I grouped them by sum, where I actually iterate over the array, group them by sum. And the thing is, here, this can be optimized. But what I have here, every sum corresponds to a heap, right? Right. And then the heap should be a maximum size of 2. I keep adding to the heap, but in a better way, I should keep pushing to the heap. And if the heap size is greater than 2, I should be popping from the heap. So basically, I think instead of maintaining a max heap, I can maintain a min heap. This is a max heap in Python, by the way, because there's no max heap. So I should maintain a min heap. If it exceeds 2, I just keep popping. I'm going to change it. Yeah, so basically, we only care about the first two elements, the biggest two elements of this heap, right? And then we're going to iterate over the hash map group by sum. If the array is greater than 1, that means we basically found the pairing. So if the heap's length is 1, that means we only found one value, so we can't create a pair with that. I pop the first two values of the heap here, and then I just calculate the max between the current res and the sum of them. And if res still is 0 after all this operation, I return -1, because that's what it returns apparently. So yeah, the time complexity is, for here, it's of n. For this part, it is... so pushing is a log n operation for how many times? For n, so it's n log n basically, but it should be n log k basically, because I don't push unless it's greater than 2. So it's gonna be, basically. No, but I popped though. Anyways, it's like probably going to be O of n the worst case. Here it's n log n, and here we pop for every time we find. So it's probably, it's gonna be n log n, I think. Yeah, that's been it, guys, for this one. Thank you, and see you in the next one.